Hello students, let us look at dimensions today. Every quantity, whether it is measured or calculated, has dimension. What do we mean by that? We know that there are many physical quantities in physics: force, velocity, acceleration. We had learnt earlier that no matter what the quantity, they all can be expressed in terms of 7 base quantities: mass, length, time, electric current, temperature, luminous intensity, amount of substance. These can be used to express any quantity. So, when any physical quantity is expressed in terms of its base quantities, that is called the dimensional formula of that physical quantity or the dimensions of that quantity. So, let us take an example. Area. What is area? Area is length into length. Length into length. Dimensions and dimensional formula, we use the symbols. So here the dimensional symbol for mass is m, the dimensional symbol for length is L, for time is T, for temperature it is K, for electric current it is I, for amount of substance it is MOL, and for luminous intensity it is CD. So when we use when we use these symbols to express a quantity, that it becomes the dimensions of that physical quantity. So here area is length into length. So in terms of symbol it becomes L into L or L square. So these are the dimensions of area. Sometimes it is written as m power 0, meaning there is no mass, L power 2 and T power 0. There is no mass, there is no time, there is only length. In physics, in mechanics, in these chapters, most of the quantities we are going to deal with is going to be mass, length and time. So sometimes it is expressed as m power 0, L power 2 and T power 0. And also to a symbol to say we are asking the dimensions of, we use square brackets. So when somebody says give me the dimensions of area, they can write it like this, a square bracket with area in between, and this would become this one here. So these are the dimensions of area. So let us see some more examples. Dimensions of velocity. Velocity is distance by time, or again length by time. So this becomes L T power minus 1. Acceleration. Acceleration is length by time square. If you don't know any of these quantities, don't worry. We will learn them in the upcoming lectures. But for now, let's go with this definition. Acceleration is length by time square, or this becomes L T power minus 2. Force. Force is mass into acceleration. Now mass, the dimensional symbol is m and acceleration is L T power minus 2. So these are the dimensions of force. Density. Density is mass by volume. Density is mass by volume. And what is volume? Volume is side into side into side, length cube. Mass is m and volume is L power minus 3. So these are the dimensions of different physical quantities. L to the T power minus 1 is velocity, L T power minus 2 is acceleration, and m L T power minus 2 is force. So what did we learn today? We learned the basics of dimensions. Every quantity, whether it is measured or calculated, has dimensions. What do we mean by that? How a quantity is related to its base quantities. What are these base quantities? Scientists have identified 7 base quantities that every physical quantity can be expressed in terms of. These 7 base quantities are mass, length, time, temperature, electric current, amount of substance, and luminous intensity. And when a physical quantity is expressed in terms of the dimensional symbol, that becomes the dimensions or dimensional formula of that physical quantity. So what are the dimensional symbols? Mass M, length L, time T, temperature K, electric current I, amount of substance MOL, short for mole, and luminous intensity CD, short for candela. So when any physical quantity is expressed in terms of these symbols, those become the dimensions of that physical quantity. So we have taken an example. Area is length into length. So the dimensions are L square. Sometimes it is written as m power 0 L square T power 0. M power 0 becomes 1, T power 0 becomes 1. So essentially this turns to L square. But sometimes it is written like that. M power 0, L square and T power 0. And to say what are the dimensions of, we use square brackets. So this means, this symbol means give me the dimensions of area, and these are the dimensions of area. And here we have seen some examples of dimensions of velocity, acceleration, force and density. In the upcoming lectures, we are going to know more about where we use dimensions and how to use them. Alright. In dimensions, let's find out the dimensions of some quantities from physical quantities so that we get some practice. What are the dimensions of speed of light? They are talking about speed. It doesn't matter whether it's light or anything. Speed. Speed is what? Distance by time. Speed is distance by time. So distance by time, and symbol for distance, the dimension symbol is L, and for time it is T. So this becomes L T power minus 1. Force. What is force? Force is mass into acceleration. Mass, the symbol is M, and for acceleration it is L T power minus 2. So this is the dimension of force. Pressure. What is pressure? Pressure is force by area. What are the dimensions of force? Force is mass into acceleration by area. Area is length into length. So this becomes, the symbol for mass is M, and acceleration is L T power minus 2. So we have L T power minus 2, and by length into length is L square, L into L. So these two get cancelled, and we have, finally we have M, L power minus 1, T power minus 2. This is the dimension of pressure. Half AT square. There is a formula which you will learn in the upcoming chapters, upcoming classes, where the distance is calculated using a formula ut plus half AT square. When the initial velocity is 0, the distance covered by an object is given by half AT square, where A stands for acceleration and T for time. So what are the dimensions of this half? Numbers have no dimensions. So we are going to find out only the dimensions of these two. Acceleration, we have seen earlier, it is L T power minus 2, A is L T power minus 2, and T square is T square. So these two get cancelled and we have L. So the dimension of this physical quantity is length. Work done. Work done in physics is force into displacement. Don't worry about what displacement is now, it is distance. Don't worry about what displacement is now, it is distance. There is a slight difference, but for now let us consider it as distance. So force into distance. Again, force we had earlier found out is ml t power minus 2. So ml t power minus 2 into displacement or distance is L. So this becomes ml t square t power minus 2. So these are the dimensions of these quantities. We need to remember this one, numbers don't have any dimensions. Let us see some more examples and then we will get more clarity. Let us see some more examples of how to calculate the dimensions of some of the physical quantities. Here we have gravitational constant g. What are the dimensions of that? There is a formula where force is equal to g, the gravitational constant, into m1 and m2 by r square. This is the equation given by Newton. When there are two planets m1 and m2 and the distance between them is r, okay, the force of attraction between these two planets is given using this formula. Here is a constant and the mass of planet 1 into mass of planet 2 or mass of two objects m1 and m2 by the square of the distance between them. This is the force of gravitational attraction between two objects. So what is the dimensional formula of g here? So now what is force? Force is mass into acceleration, that is equal to g into, this is m is mass, m2 is another mass, and by r square. R is the distance between the two objects, which is the length. So that is length square. So here we have mass m, acceleration is length by time square, L t power minus 2 is equal to g into m square into L power minus 2. So this becomes, if we get all of these this side, then here it becomes g is equal to m L t power minus 2 divided by m square and L power minus 2. Because this is L power minus 2, g is equal to 1m get cancelled, g is equal to m power minus 1. This goes up, so that becomes 1 plus 2 L cube t power minus 2. So this is the dimensional formula for gravitational constant. If you don't know any of these, that's okay, we'll learn in the further classes, but for now let's go with whatever is on the board here. Another constant, gas constant. What is the dimensional formula for R? So there is another formula, PV is equal to nRT, where P is pressure, V is volume, V is volume, and N is number of moles. Number of moles, that is the amount of substance. Number of moles is the amount of substance. Num of moles into R, the gas constant, into T is the temperature. Now, what is pressure? Pressure is force by area into volume. Volume is, the dimensions are L cube, is equal to number of moles is MOL. That's the dimension of number of moles, MOL into R into temperature. Temperature is, oh, we did not write here. Okay. Temperature, the symbol is K. So K for Kelvin. K is for Kelvin. Okay. So let's transpose all of this here and this that side. So this becomes MOL into R into K is equal to force by area into L cube. So what is this? MOL into R into K equals force is ml t power minus 2, ml t power minus 2 by area is into L power minus 2 into L cube mole into R into K equals ml power 1 minus 2, that becomes ml power minus 1. Oh, there is a 3 here. Okay. So plus 3 minus 2 is plus 1, plus 1 plus 1 is 2. So ml power 2 and what do we have? T power minus 2. T power minus 2. So R equals m L square T power minus 2, mole goes this side, mole inverse, K goes that side, K inverse. So this is the dimensional formula for gas constant. Okay.